Hello and welcome to the video presentation of the PePa ping dataset, a comprehensive contextualization of periodic passive ping in wireless networks. My name is Diego Madariaga and today I will share with you the key points of our work. However, this is collaborative work with a group of experts in computer networks from the University of Chile. The outline of this presentation is as follows. Firstly, I will give a brief introduction presenting the context and motivation for this work. Secondly, I will present the network measurement methodology employed in this study. Next, we are going to talk about the generation of the presented dataset. And finally, we will look at some use cases for our dataset. As the primary motivation, we were interested in studying the quality of mobile networks, with a particular focus on the quality that end users are actually receiving. Therefore, we had the idea of developing a mobile crowdsourcing application capable of measuring the quality of the mobile network from inside end user devices. As we wanted to measure the network from real-world users in real-world scenarios, our measurement application had to be designed paying special attention to the users. Specifically, we wanted to measure the network quality without disturbing users, so that they would not uninstall our app. We identified some requisites for our crowdsourcing application as we were planning for user adoption. Firstly, we wanted to interfere as least as possible in users' devices. In particular, we wanted to have a low impact on the battery of users' smartphones. Thus, we decided not to measure network quality all the time. Instead, we chose to implement our measurement application as a periodic monitoring system. Our claim here is that with enough periodicity, we can still obtain a good representation of the network usage without overloading the user's devices. Secondly, our application should not impact users' internet traffic, because we didn't want to exhaust their internet data plans. Also, we didn't want to deteriorate the user experience by reducing their bandwidth. Therefore, we decided to follow a passive measurement approach without injecting any new packet into the network. Thus, we had to measure the network quality based only on observation of users' traffic. Another important decision we had to make was to define what to measure with our mobile application. Most of the related studies have mainly focused on the throughput to measure the network performance. However, we were also interested in other aspects of network quality that can help determine the reliability of internet connectivity, such as latency, jitter, and packet loss. As can be seen, this is very similar to the information provided by the ping utility. Consequently, we investigated the possibility of obtaining this ping-like information from all active connections simultaneously. We analyzed some solutions to this specific problem that have been described as passive ping approaches. These existing solutions allow the analysis of round-trip time and packet loss for every network flow, without inducing a traffic overload that could affect their measurements. However, all of these solutions have a significant drawback. They require root privileges to work correctly, and therefore these passive ping approaches didn't fit well for our purposes, as we would not ask our users to root their smartphones. Our solution implements an Android VPN service in order to gain packet-level access without requiring root privileges. Then, we implemented a packet forwarder system in C++ to send and receive IP packets. Inside the packet forwarder, Each Internet connection is represented by an application-level socket. Thus, while our measurement system is running, each connection established from the user device will be managed by an individual socket in the packet forwarder. Finally, the packet forwarder can obtain information from all these sockets: the protocol used, IP addresses, ports, start time and end time, transmitted byte and received bytes. In addition, we can access ping-like information from each TCP connection directly from the Linux kernel, such as the estimation of the round-trip time and jitter. Considering the requirements previously identified for user adoption, we decided to run our passive ping approach for 1 minute every 15 minutes. So with our periodic passive ping or PePa ping methodology, we can periodically measure the network quality from an end-user device. Then we can obtain information from all the Internet connections, and also we can obtain ping length measurements from all TCP connections. In addition to this information, we designed our Android application to collect contextual information in parallel of each 1-minute execution of PePa ping. This information allows for a better understanding of the condition in which the users were accessing the Internet. This contextual information includes Internet connectivity changes between Wi-Fi and cellular, network signal changes, including information about signal quality indicators and the presence of handovers, Wi-Fi signal changes, and information about RAM usage. However, for a complete list of the contextual information, please refer to the project repository. This figure presents an example of the information collected by our measurement application in a given 1-minute execution. The figure shows some Android applications that establish connections of different time lengths throughout the 60 seconds of measurement. In addition, a variety of contextual information is also displayed as a set of time series accompanying the connections. Here we have 3 signal quality indicators and the percentage of used RAM. These time series provide a comprehensive contextualization of the 1-minute execution, describing all the temporal changes in detail. Moreover, these time series provide a precise contextualization of every single connection established. Similarly, this second figure shows another example of an execution of our measurement methodology. Again, we have different applications establishing Internet connections using the mobile network. Some of these connections experience a vertical handover between two different mobile network technologies. It is important to notice that we can precisely determine which connections were affected by the handover events and which were not. In addition to the information collected directly by our Android application, we collected some external information related to the destination IP and port of each network flow in our dataset. For example, the service running in each destination IP and port, information about the autonomous system associated with each IP address, and information about who managed each destination IP address. To generate the presented dataset, we conducted a recruitment campaign and distributed our crowdsourcing application to people in the city of Santiago, Chile. We collected information from 137 real users who voluntarily accepted installing the application on their personal devices. In total, we registered information about 220,000 executions of the 1-minute measurement system. Thus, the monitoring system analyzed 3,200,000 Internet traffic flows. These connections were established by more than 1,000 different Android applications. The PePa dataset is publicly available and it can be downloaded from the project repository. The repository includes the instruction to restore the database locally, in addition to a detailed description of the dataset structure. The presented dataset contains valuable information about network usage, empirical quality of service of the TCP flows, and a comprehensive set of mobile users' contextual information. Thus, we provide a useful source that can be of great importance to a variety of studies related to network usage behavior and network performance, such as analyzing the reliability of Internet connectivity, analyzing the adoption of network protocols, study the effect of handovers on the performance of users' connections, study the relation between user experience and different network metrics, or combine a variety of metrics to study round-trip time and throughput prediction. Thanks for your attention.